Hello everyone. In the beginning of the class, let us see new announcements. Okay, the first new announcement is June 1st, 2022 class videos uploaded. Hello everyone, I have uploaded the class videos on June 1st, 2022 to YouTube. Their URLs are this, and this. I uploaded part 3 on June 2nd, 2022. I apologize for the delay and any inconvenience caused. Best regards, Wei Zhen. Okay, the second new announcement is the slides of Chapter 4 have been updated. Version 2022-0602. Hello everyone! I have uploaded the latest version of the slides of Chapter 4 to the eCourse2 website. The location and the file name are eCourse2 website, multiple input, multiple output techniques for wireless communications, course content, slides, chapter 4, slides 2022-0602.pptx. Best regards, Wei Zhen. Okay, the fourth new announcement is the slides of Chapter 4 have been updated, version 2022-0606. Hello everyone, I have uploaded the latest version of the slides of Chapter 4 to the eCourse2 website. The location and the file name are eCourse2 website, multiple input, multiple output techniques for wireless communications. Course content, slides, chapter 4, slides 2022-0606.pptx. Best regards, Wei Zhen. Okay, and the next new announcement is the handout of Chapter 4 has been updated, version 2022-0606. Hello everyone, I have uploaded the latest version of the handout of Chapter 4 to the eCourse2 website. The location and the file name are eCourse2 website, multiple input, multiple output techniques for wireless communications. Course content, handouts, chapter 4, handout 2022-0606.pdf. Best regards, Wei Zhen. Okay, the next new announcement is the slides of Chapter 5 have been updated, version 2022-0606. Hello everyone, I have uploaded the latest version of the slides of Chapter 5 to the eCourse2 website. The location and the file name are eCourse2 website, multiple input, multiple output techniques for wireless communications. Course content, slides, chapter 5, slides 2022-0606.pptx. Best regards, Wei Zhen. Okay, the next new announcement is the handout of Chapter 5 has been updated, version 2022-0606. Hello everyone, I have uploaded the latest version of the handout of Chapter 5 to the eCourse2 website. The location and the file name are equals to website. Multiple input, multiple output techniques for wireless communications. Course content, handouts. Chapter 5, handout 20220606.pdf. Best regards, Wei Zhen. Okay, next let us look at the progress of the last class. Okay, in the last class we have taught to chapter 4 slides, page 181 finished. So please open the slides of chapter 4. Excuse me. Okay, and turn to the page 182. Okay. We now consider discrete time instance Tk. Okay, we are talking about frequency selective fading. Tk is equal to K over W. Okay, what is W? Okay, let us see, review the meaning of W. Okay, W is the bandwidth of the signal. Okay. Okay, where K is equal to 0, 1, etc. So K is K can be any non-negative integers, and establish the following definitions. S of K minus L is defined as U of K minus L over W. Okay, what is U? Okay, function U. Okay, let us review the meaning of function U. Okay. Okay, U of T is a signal. Okay. Okay, so the equation number is in the wrong place. Okay, let me fix it. Okay. Okay, next, HL of K is defined as 1 over W times small c of K over W, L over W. Okay, what is the function small c? Okay, let us review the meaning of small c. Okay, this is capital C. Okay, small c. Okay, so C of T tau is the impulse response function. Okay, so it is on page 55. Okay, let us go back to page 182. Okay, so this equation number is in the wrong place. Okay, let me correct it. Okay. Okay, and z of k is defined as z of k over w. Okay, what is the function z? Okay, let us review the meaning of function z. Okay, z of t is the thermal noise term. Okay, so this equation number is in the wrong place. Okay, let me correct it. Okay, good. Okay, substituting these definitions into equation 4.46. Okay, let us see equation 4.46. Okay, in equation 4.46, we can see that r of t. Okay, what is r of t? Let us review the meaning of r of t. Okay, here on page 53, R of t is the received low-pass equivalent signal. Okay, let us go back to page 183. Okay, substituting these definitions into equation 4.46. Okay, 4.46. Let us review this function. Review this equation. R of t is equal to summation small l is equal to 0 to capital L minus 1, where capital L is the number of simple periods in Tm, and Tm is the channel impulse response duration. Okay, U of t minus L over W times 1 over W times C of t L over W plus Z of t. Okay. So R of k is equal to R of k is equal to summation small l is equal to 0 to capital L minus 1, and HL of k times S of k minus L plus Z of k. Okay, this equation number is in the wrong place. Let me correct it. Okay. Okay, this equation is the system equation for a SISO system operating in a frequency selective fading environment. We note that unlike equation 4.41, okay, let us go to equation 4.41. Okay, in equation 4.41, we can see that R of k is equal to H of k excuse me, times S of k plus Z of k. Okay, where R of k is defined as R of tk. Okay, this equation number is in the wrong place. Okay, let me correct it. Okay. And what is h of k? Okay, let us see. H of k is defined as capital C of tk0, where capital C is the channel response, okay, or frequency response. And S of k is defined as U of tk, and Z of k is the noise. Okay. Okay, we note that unlike equation 4.41 for flat fading, in frequency selective fading, the effect of the channel is not a simple complex gain applied to each symbol. Okay, we can see that it is not a simple complex gain applied to each symbol. Okay, it is the convolution. The expression in equation 4.50. Okay, let us see equation 4.50. Okay, this equation, we have seen this several minutes ago. Does not impose any constraints on the variances of the individual components. For simulation purposes, however, it is often convenient to assume the following normalizations. Okay, summation small l is equal to 0 to capital L minus 1. The square of the absolute value of HL of k is equal to 1. Okay, the equation number is in the wrong place. Okay. So let me fix it. Okay, good. Okay, so the communications meaning of this equation is that the channel power is equal to 1. Okay, and then expectation of the square of the absolute value of S of k is equal to 1. Okay, this equation number is in the wrong place. Let me fix it. Okay. Okay, so the communications meaning of the equation is that the average power of the transmitted signal is equal to 1. Okay, and the expectation of the square of the absolute value of Z of k is equal to 1. Okay, the equation number is in the wrong place. Let me correct it. Okay. So the communications meaning of this equation is that the average power of the noise is equal to 1. Okay. When this is done, equation 4.50. Okay, let us see equation 4.50. Okay, this equation, we have seen this equation just several minutes ago. Okay, equation 4.50 must be rewritten as follows. Okay, we can see that R of k is equal to the square root of rho times summation small l is equal to 0 to capital L minus 1. HL of k times S of k minus L plus Z of k. Okay, the equation number is in the wrong place. Let me correct it. Okay. So let us compare this equation and equation 4.50. Okay, you can see that the only difference between these two equations is that equation 4.54 has a term, the square root of rho before the summation. But in equation 4.50, it does not have the term square root of rho before the summation. Okay, for a MIMO system, the normalizations would be the same, except equation 4.52. Okay, let us see equation 4.52. Okay, here the expectation of the square of the absolute value of S of k is equal to 1. Okay, that is the average power of the transmitted signal or symbol is equal to 1. Okay, so except equation 4.52 is replaced by the expectation of the square of the absolute value of S of k is equal to 1 over nt. Okay, where nt is the the number of transmit antennas. Okay, because there are nt transmit antennas, and here we do not assume that the transmitter knows the channel state information, that is CSI. So the average power of each transmit signal is equal to 1 over nt. Under that assumption, okay, that is this assumption, the system equations in frequency selective fading become this equation: Ri of k is equal to the square root of rho times summation j is equal to 1 to nt. Summation L is equal to 0 to capital L minus 1. Hij of k times Sj of k minus L plus Z of k. Okay, for I is equal to 1 to Nr. Okay, where I appears here. Okay, and appears here. Okay, so Nr is the number of received antennas. So we can know that Ri of k is the received signal at the ith received antenna at time k, where Hij of k denotes the set of channel impulse response values on the path between transmit antenna j and receive antenna I at time k. Excuse me. We use this form of the system equation in chapter 9 when we talk about the use of MIMO in frequency selective channels. Okay, next let us go to section 4.5.3, slow and fast fading. Okay, definition: when the channel changes slowly relative to the rate at which the signal varies, the channel is said to undergo slow fading. Okay, what is the meaning of the word undergo? Let us see the handout. Okay, please open the handout of chapter 4. Okay, here. Okay, and please search for the word undergo. Okay, here. So on page 191, problem 1, what is undergo? Solution: to experience something that is unpleasant or something that okay, it is 25 minutes. Let us take a break.